We have already talked about aldehydes and ketones briefly last chapter when we had them as products of alcohol oxidation and when we did the quick introduction to functional groups. In this video, we're just going to review quickly what those two functional groups are and how we can pick them out of a structure. So ketones and aldehydes are both what we call carbonyl functional groups, meaning that they have a carbon-oxygen double bond. What is different about them is what is on either side of that carbon. If both groups are carbon chains, which we do tend to represent with R's, they can be different or the same. This is a ketone. If one side is bonded to a carbon and the other side is bonded directly to a hydrogen, this is the aldehyde. A few of the other carbonyl functional groups that we have seen, we did talk about carboxylic acid, which we will see again this chapter. We also have an ester, where one side is an R group, the other side is an oxygen, and then another R group. And we can also have what we call an amide. So one side is an R group and the other side is a nitrogen. And that nitrogen can be attached to either two more hydrogens or two R groups as well. So the primary focus of this chapter are the ketones and the aldehydes. We will again see carboxylic acids in some of the reactions that we will look at. Let's look at a couple examples and just practice identifying these functional groups. So what functional group is in this structure? What you want to do is focus in on that carbon-oxygen double bond, that carbonyl, and then you're going to look to see what is attached on both sides. So if I look to the left, what I have attached is a carbon, and it's attached to other carbons. I don't really care about what those are. It's really what that direct bond is to. On the right side is attached to another carbon. So both sides are R groups, making this a ketone. If I look at this structure, again, I have that carbon-oxygen double bond, the carbonyl. Left side and right side. The left side is attached to a carbon group and the right side is attached directly to that hydrogen. This makes it an aldehyde. I'm going to give you two more examples. You can pause the video and decide what each one is. All right, if I look at the structure on the left, I'll pull out that carbon-oxygen double bond, the carbonyl. I see that on one side it is directly attached to a carbon atom, and then the other side is directly attached to the hydrogen. So this is an aldehyde. In the second structure, I have that carbon-oxygen double bond. One side is directly attached to a carbon, as is the other side, making this a ketone.